First, we're going to talk about property checks. Ensuring iProperties are filled out is usually rather important. iProperties are shown on parts lists as part of your bill of materials, could be in the title block of your drawing. So it's something that you want to make sure is filled out. And one of the most common basic things, so then again, it's one of the favorites, is checking to make sure certain iProperties are filled out. If I open up my iProperties on this part, and we'll take a look at the title. Here we can see that it's blank, and then we'll also take a look at the description iProperty here. So what this rule is going to do is check to make sure that either title is not blank or description, I should say, and description is not blank. It'll look at each one of those. If either is blank, then we're going to throw up a dialog box and allow the user to populate those iProperties. Okay. This rule is set up on an event trigger. Event triggers are used to launch certain rules at certain events. So if I take a look on my Manage tab in my iLogic panel, here is my event triggers. And again, we're looking at this document only, and I have a iProp check rule underneath my before save document event. So before it actually saves, it's going to run this internal rule called iProp check. Okay, I'll go ahead and cancel that dialog box. I'm going to come up and hit the Save button, and there is the form that popped up. Right, the rule ran. The rules checked to make sure if either of those are blank. So I'm going to go ahead and put in a title here of bar clamp. Right. Okay, that dialog box. You know, I think I'm all good to go. I go back up, I hit save again. Well, right, the description iProperty is still blank, therefore I still get the form here in order to fill it out. So if I fill out that guy now, hit OK, go to save, and we're all good, right? The rule does not launch the form again. I pop open those iProperties, we'll see that I am actually populating that title iProperty and then the description iProperty. Now that before save event, again, when I go hit the save button, that event triggers, therefore the rule runs. Even if I cancel that, I'm not stopping that document from saving. Okay? Just be aware of that I'm not doing anything to keep that from happening. I'm just trying to make sure that the user knows, hey, these things that are supposed to be filled out are not filled out. Okay? So next thing we're going to talk about is some feature creation. Quite often when we're using iLogic to build, say, a configurator, we're using it to control the suppression states of certain features, right? Based upon whatever selection the user might have made, I may need certain features, or I don't need certain features. In this case, we're going to end up building a feature on the fly with our rule. It's going to find this front face of my sheet metal component here, start a sketch upon that face, add some sketch entities, adding some geometric constraints or some dimensional constraints, you know, whatever is required, and then go ahead and create the feature out of it. All right, so I'm going to go ahead and run my rule here. It is set up as an external rule. So if I take a look over in my model browser now, I have an additional feature here called the rectangular cutout. I expand that. I have a feature sketch. I'm controlling the names of these, right? I can name that sketch whatever I want to name that sketch. I can name that feature whatever I want to name it. If I take a look at the sketch in here, we'll notice that we are fully constrained, right? It is a 2-point center rectangle, and then I've got the width of that thing dimensioned, and I've got the overall height of that dimension. Again, that's being built on the fly. I can control what those values are, right? If I know what size that rectangle needs to be, I can size that however I want it. Okay? And this is a relatively simple sketch, and it's a relatively simple feature as well. It's just a sheet metal cut. Okay. So another example of that, something a little more complex. Again, we're dealing with the sheet metal part here. But it's going to add additional profiles, so we'll see multiple entities in our sketch. I'm going to go ahead and run this feature creation 2 here. Same thing there. I now have a lock clearance hole feature. I did choose to put both of these in the same sketch. Again, I could do this however I wanted. I've got as much control over those as I need. Okay, and we have a couple different kinds of entities going on in here. I've got some diameter dimensions, and then as well as an offset dimension controlling the 20 millimeter distance there between those two. Okay. Now, both of these rules, the feature creation rules, take into account what are called attributes. If you're doing anything like this where you're dealing with stuff on the fly, you want to look into attributes. An attribute is a way of assigning a particular attribute to a face, for example. And this front face, where I'm choosing to make that sketch, has an attribute named front face in this case. Okay. The same thing over in this other guy over here. I've applied an attribute to this. Now, attributes have been in Inventor for a long time. Just recently, they allowed us to start creating these on the fly with this assign name function. Okay? That is really creating an attribute. It just calls it a little bit different. It makes it more user-friendly. But I can do the same thing with something like this. I can assign a name to that entity and then therefore find that entity later on when I want to do something with the code. Okay, I'll go ahead and cancel out of that thing there. So let's look at some other sheet metal stuff. One is exporting flat patterns to a DXF, right? A very common thing. Just about anybody who works with sheet metal is probably familiar with. You need a flat pattern for manufacturing process. It's a very tedious thing to do on a one-by-one case basis. Therefore, it's a great thing to do with automation. So in this case here, I've already got a flat pattern. If there wasn't a flat pattern, the code would check to make sure. If it's not there, it makes it itself and then goes ahead and exports that DXF. Okay. So we'll look on a single case-by-case basis here. I'm going to go ahead and run my sheet metal export DXF. Not very exciting, right? I'm not seeing a whole lot of stuff happening out there on the screen. It is done now. I go ahead and open, and then I'll switch my file type here to DXF. And then we'll see here, that's that feature creation one that's at 219, right? That's the one that just created. I'm going to go ahead and bring that up in Inventor just so we can look at it. So there's my flat pattern. Let me move the view over a little bit so we can see it. I've also done some additional things here. I'm changing the layers, right? So that outer profile I'm making magenta. The inner profile I've changed it to color green, right? So we can differentiate depending on what type of thing or utility you're sending this out to. Maybe it runs off of colors or off of layer names or something like that. Okay. I'm going to jump back over here to my secondary one. I'll go ahead and run it on this guy as well. Again, not a lot of pretty things happening on the screen. Let me pull that DXF up. Feature creation 2. Of course, if you're doing something with the Inventor nesting utility, obviously you wouldn't have to be going through this process. You could use it for getting these flat patterns out of it. And then even certain other newer controllers don't even require the use of a DXF either. They could take that native Inventor file. But there's the DXF. Again, I'm doing the same thing there. I'm modifying some of those layers upon export. Okay, so that's running that rule against one individual piece, whatever my current document happens to be. If you've got an assembly that maybe has a couple hundred, a couple thousand, whatever sheet metal components in it, obviously that's not something you'd want to do on a case-by-case basis. With just about anything, working from the assembly level down through all of the components is something that very commonly happens. So in this case, we've got some sheet metal components inside of this assembly. And again, rather than opening up each one individually, running my export rule, I can run it kind of in a batch mode here against that entire assembly. So what this is going to do is traverse through the assembly, looking at all the components, right? If I flip down here through my model browser, you see there's some assemblies, there's some separate components. There are some sheet metal parts, right? I see them because of the icon here. There's also some sheet metal parts out in some of these lower level components, or I should say lower level subassemblies. So what the rule is going to do is look at every single occurrence. If it's an assembly, then it also dives down into that assembly. In the end, it's going to look at everything that's out on the part of it. Okay? So I'm going to run this sheet metal flats rule here, and we'll actually see some of them fly up on the screen. I kept it to open those visually so we can see what's going on. It's not something you have to do. You could, again, just have it running in the background to where you don't see what's happening. But it's skipping some parts. It's finding all the parts that are sheet metal components. It's editing the flat pattern, and then it's exporting that flat pattern again as a DXF file. So here is, let me pull that over. I'm throwing all these into a specific folder here. So you can see those DXF files starting to populate and build inside of that folder. In this case, there's also some duplications of some components. Some of those parts might be used in multiple places. I've got a check in there. I'm keeping a running array of all the parts that I've processed. So if a part's in there 10 times, it's only going to process it once. The next time it comes across it, it's just going to skip it. Okay? And then I threw a little dialog box up there at the end that says that DXF processing is complete. Okay? So again, cycling through all entities or all occurrences inside of an assembly in order to do something with it is a quite common occurrence that happens when when you're doing something more like a configurator, right? At the end of it, I'm done with, I've made all my selections. Now go spit out all of my DXFs for either post-processing or sending right out to the floor. Okay. Excuse me. So another example here of something is to, let me switch my mode here for my part priority. Take a look at one of these parts. And we'll look at his parameters. There are no user parameters as you can see here. So I want to be able to show the flat pattern width and then the flat pattern extents so that I could use that for, say, in my parts list, right? I want to list out the flat length and the flat width for each one of my sheet metal parts inside of my parts list on my drawings. So another thing we're going to do here from the top level is run through and again look at all sheet metal components. And if it is a sheet metal part, I want to take a look to see if there's existing parameters called flat pattern length and flat pattern width. Okay? If those exist, fine and dandy, I just move on. If they don't, I'm going to create them on the fly. And then I'm going to set those parameters to be exposed as an iProperty. Right? There's a checkbox over there in your parameters dialog box. Therefore, those iProperties can then be used, again, inside of my parts lists. I'm also going to set some of the custom format precision. I think I'm setting these to 3 decimal places. I'm turning off the trailing zeros. I'm turning off the unit string. You know, all of those other options that you have inside of that regular parameters dialog box, we can do with code as well. And in this case, I'm making an assumption that the longer of the two is going to be the length, and then obviously the less of the two is going to end up being the flat pattern width. Okay, so if I take a look at my bill of materials for this guy and look at the parts only, I've already exposed the flat pattern length and the flat pattern width iProperties. If I scroll down here and I look at some of these sheet metal components, right, I can tell again by that icon, there's nothing in any of these flat pattern lengths or flat pattern width iProperties as of yet. So I'm going to go ahead and again run my sheet metal parameters rule here. Again, nothing exciting going on the screen, and it's that quick, it's over with. So if I pop open my bill of materials now, all of these components that are sheet metal, you'll notice over here I have populated with what the flat pattern length and the flat pattern width values are. Okay, and again, for use on my parts list. If I pull open that part again, pop open his parameters, we'll see that there is a flat pattern length and then a flat pattern width, and then pull that over a little bit. They are set to export, and then, I turned off the unit string. I guess I left the trailing zeros and I set it to 3-place precision. Right, so you can control any of that stuff that you end up wanting. If you want to change the format to fractional, right, all of that is possible doing that. Alrighty. Let me go ahead and close that guy. The next one I want to talk about here is something that's more of a utility. Quite often when you're, again, building a large configurator, you're going to have a large number of parameters at the top level. So let me jump out here, and I'm going to open up a spreadsheet. Rather than creating those parameters individually from that top level assembly or even down in the lower level pieces, I've built them as a spreadsheet here. So over on the left, we see the name, right? These are the names of my parameters. The unit of measure is going to be what type it is, right? Is that a numeric? Is that a Boolean? Is that text? I've even got an angular one down here with degrees. I've got the expression. That's going to be what ends up in the expression column of my parameters dialog box. My is key is the is key column. Let me pop open one again here real quick. That's this guy over here, right? Quite often used for, if you have a lot of parameters, it's used for filtering. Right down in the lower left, I can switch and to look at just key or non-keys. Quite often, I will use it for those parameters that I want to show up on my iLogic form. Right, I'll set those as key and then filter them out when I'm building my form. Okay, and then there's also an export parameter option listed here in my spreadsheet. I'm also throwing some comments. I talk a lot in class about using comments, especially if it's something complex. You've got some complex formula over in the expression column here. Do yourself and those who work on your parts a favor and put in what you're doing there inside of that comment section. But again, rather than individually creating these on a case by or on a line by line basis in that assembly or even in a part, I can read them out of this Excel file and create them on the fly. It also makes it much easier when I have things that are listed, multiples. I've got 4 steps in this thing. So I can use the standard Excel tools in order to make copies of those things. Okay. So I'm going to go ahead and close this Excel file, go back to Inventor. I'm going to start a brand new blank assembly. Right. I'll pop open the parameters. We've got nothing in this parameters as of yet. So I'm going to run my create from Excel. The path to that Excel file, in this case, I do have that hard-coded, but it is going to go in there and look at all the sheets that are possible and ask me which sheet do I want to read in data from. In this case, I only had the one sheet. It's called add, right? So I'm going to hit OK there. I'm going to pull up my debug view just so I can see what's going on. A lot of this stuff running in the background, it's accessing that Excel file. Sometimes accessing Excel file might take a little bit. We can see there that it ran through and it created everything, and I get a message down there at the end that it says that that rule is now complete. So if I open up my parameters dialog box, right, there's all those parameters. They've got the unit types as I set them, all the values as I set them, the comments are there, etc. Again, it saves me a lot of time at the offset of a project where I know what certain parameters are going to end up being. I can keep them in order. I can quickly create them. Okay, doesn't have to be an assembly. Again, that can be from in a part file as well. Okay. So let me close that guy. Let's talk a little bit here about creating drawings. Model-based definition over the past few years has gotten some traction. A lot of us still have to build a 2D print, right? I still need that 2D drawing that can go out to the shop floor. Creating drawings from scratch inside of Inventor can be done. It can be a complicated endeavor depending on what's going on. What I'm going to end up building here is a rather simple drawing. I'm going to open up a little form here. All right, I can modify the thickness, the length of my part, the width, whether or not I need a hole in there, I don't need a hole in there, what size the hole is, and then some colors. Right. On this first one, I'm going to leave the hole off so I can talk a little bit about what's going on inside of that code. And I do break it down to making the views and then making some annotations. Okay. So I'm going to hit the Create Drawing button. And again, it's doing this from scratch, right? Let me move that dialog box out of the way. It just created a new drawing. It used a specific template that I told it to use. It made a front view and then a right view. Again, I know what views are required in this part. Therefore, that's what's happening with this. So one of the main things about creating drawings is you have to understand all of the possibilities that might happen. Okay, I'll show you here when I say yes to my dialog box about the annotations. So there it created a length dimension and then a width dimension, a stock dimension, and then the thickness dimension as well. Again, I'm showing this as blue. I have complete control over how those dimensions look, what dim style you're using, what layer they're going to end up putting on, etc. Because I didn't have that hole, I'm obviously not dimensioning a hole. My 6-inch length dimension is a certain distance off, right? So I'm going to go ahead and close this. I'm not going to worry about saving it for the time being. I'm going to turn that hole on, and this time I'll switch to a blue color. Hit Create a Drawing again. Tell it yes to make some annotations. And notice now I'm getting dimensions for that hole center. My 6-inch length dimension is spaced off a little bit further, and I'm also getting that hole note. Okay, so again, you need to understand all of the possibilities that might be happening. In this case, I'm looking to see, is there a hole or not? If there is not, I'm only spacing that first dimension there so far away from my part. If the hole is there, I know I have to move a little further because this 3-inch dimension is going to be here. Okay. So something pretty similar is this the simple part. I'll go ahead and run the rule on this guy. I did not split this out separately. It's just going to go run and do everything that it needs to do. Again, I'm choosing a specific view to apply. I'm choosing dimensioning my side views. In this case, I'm also throwing up a general note down here on the drawing. Okay, so just about any annotation that I could get from up here on my annotation tab of my ribbon is possible through code. Okay, what's also possible through code is that model-based definition, that MBD or 3D annotations, whatever you want to end up calling it. So I'm going to go ahead and run this guy, and now I'm annotating it right here on my part. Again, it's gotten some more traction over a few years, annotating everything that needs to be done in the 2D drawing, but I'm doing it here in my model. Okay, and something just a little bit more complex is a different motor plate, and in this case, again, I'm throwing on center lines, I'm doing some leaders, I'm doing some surface finish symbols, etc. And again, all of this data is being generated on the fly with automation tools. And by the same token, I can do that, those annotations on here as well. Okay, I'm omitting paint, my surface finish symbol. There are some things that aren't available, that aren't exposed in the API. You can do basic annotations, dimensions, leaders, surface texture symbols, whole notes, and general notes. Notice I have a general note up here in the upper left corner there for the deburring. Things that are not yet supported are doing tolerance features, compound annotations, or modifying the tolerance type on a linear model dimension. Okay. There's nothing special about these once they're created with code. They'll work just the same as if you manually created these. Same thing for the drawings. Right? If I jump over to here, that's a standard dimension, as if I came in here and typed the STK or the stock back behind it. There's nothing special about that. If those parts were to update, right, I made that thing 6 inches. If I come in here and modify that to 4 and go back to my drawing, right, there's nothing special about that. That's going to update as it normally would. Notice my dimension's not moving. If I were to kill this and create it from the beginning, right, we would center that because my code is telling it to put that dimension text in between my extension lines. Okay. So one other thing with drawings is copying iProperties from the part down to the drawing. In this case, if I take a look at my title block, notice I've got an area down here for paint, and then I've got an area for the area. These are iProperties that are being calculated inside of my part. And then we have a rule that I can copy those iProperties from the part level over to the drawing. Okay? Now it knows that this is supposed to be blue, and that's the complete area of paint for that part, for all those spaces. Not counting the hole, I don't think I'm removing the area for the hole. Okay? So again, copying my iProperties from the parts that's being used in that drawing over to that drawing. Therefore, when they all go into Vault or whatever, you know, everything's synced, everything looks good. Okay. And then one more thing here on drawing creation is working with an assembly. So we can create drawings of assemblies. We can pop on parts lists, and we can throw on balloons. Okay. So let me go ahead and run my rule here for creating an assembly level drawing. So again, creating a template from scratch. I'm choosing what views I need to put on there. I'm placing a parts list in a specific location on the drawing, and then I'm also throwing some balloons on there. Okay. Balloons are a little tricky. I shouldn't say tricky, I should say they're very tricky. Again, I'm using attributes for those. I know what edge I can go find for a particular part, and then I move a certain location away from that edge in order to place that balloon. Okay. So I think I might have had 11 or 12 there maybe. I wasn't necessarily keeping count. But that's it for my presentation. So, Mr. Carl, if we want to open up for Q&A.
Randy, those all look really good. I can see, see a lot of evidence why those are favorite routines, at least from an academic standpoint. And keep in mind, folks, there's lots of stuff here that can be expanded upon. When we were doing the sheet metal environment, I mean, you can build in rules. You can build in a subset of rules there that's going to check to make sure that, as it unfolds geometry, that it looks for collisions and warns you or creates a report to tell you, there's all kinds of stuff that can happen here. I noticed some comments in the chat questions about it. You can explain how you did this and all those types of things. Let's put it this way. We would have like a 3-day seminar if we were walking through lines of code and what we did and explain how they all works. Several of these, especially from the drawing environment, talk to the API. So they're not just snippets that are inside of iLogic. We're working with the API and talking to those. So the code's all there. Some of the external files are written a little differently and all that kind of stuff. What we'll do, it's kind of hard to distribute. There's a whole bunch of people on this session right now. So what we'll do is zip all these files up. These are all pretty academic. None of them belong. There might be one or two of them that are proprietary because they've got customer names attached to them. But Most of them are pretty pretty generic. So what we'll do is we'll have these things all zipped up and made available to you, and have you reach out to your account manager or send an email or something like that, and we'll provide these as a zip format. Again, it's coming with a caveat of two things. Randy's using Inventor 2019, so if you're using something older than that, of course the models won't open. Number two, they don't come with support or anything like that. So if you're not familiar with the API and you want to tweak it to make it your own or make it work with your own models and all that kind of stuff, we're just providing them as they are. I mean, they're snippets to be able to use and leverage from there. So we'll have that done in the next couple of days, get them all zipped up and provided for you. Other than that, Cassie, would you like to have some questions brought to us?
Yes.